Today we'll see the concept of circular queue. What is meant by circular queue? A queue in which last node is connected to the first node. Okay, so what does this mean? Consider I have elements like 20, 30, 62 and 15 are in the queue. Okay, now front equals to 0, rear equals to 3. Okay, so I try to delete my first element. Then what happens? Front will be incrementing. So here is front and here is rear, right? So front became 1. Now I try to delete one more element. Now front again incremented. Front equals to 2. Rear is same. Okay. So previously in the queues we have seen a disadvantage. Even if there is space over here, you cannot add elements here. Right? It only checks for rear equals to n-1 condition. But here, what I have done was, I've connected my front element and rear element. Okay? That means, after filling here, okay, after my n-1 space is filled, I should directly go back to my front connection node. Right? So, we'll see how it is going to happen. So, if you directly perform increment and decrement just like you, it won't get connected. So for this connection, we have a formula called, in case if you want to NQ, rear, you have to update the rear now. Rear equals to rear plus 1 mod size. Okay. Rear plus 1 mod size. So we'll see whether this is working or not. Okay. So now what is my rear? 15. Now I want to NQ an element. My element is 17. Okay. So for this, what did I tell you to do? Rear equals to rear plus 1. What is my rear? 3 plus 1. What is the size? 4 mod 4. 4 mod 4 equals to how much? Remainder? 0. Now rear equals to 0. Okay, so now the new element will be added at Q of 0 equals to 15. Okay. So now my rear is pointing to this element. Okay. I hope you understood. Now we'll try to insert one more element also now. I have inserted one more element NQ. 32. Okay. Now rear equals to, what is my rear right now? 0 plus 1 mod size equals to 4. Now it becomes mod 4. Okay. So what happens? 4 zeros are 0. Remainder is 1. So new element will be stored at 1's location. So my rear is updated to, okay, this is how you insert elements in the circular queue and perform updations, right? You can directly, you won't directly increment or decrement just like queues. If you want to perform a circular queue, after finishing the last position, it should get connected to the first position. This is the formula we use for NQ operation in circular queue. Okay. So we'll see some more examples. Now, how does deletion happen? Right? We should know how the deletion also happens, no? Now, what is my front right now? Front equals to 2. Okay, for deletion also the same, almost the same formula is applied. See the formula. Front equals to front plus 1, right? Mod size. What is my front? 2 plus 1. What is the size? 4. So 3 mod 4. Okay. 4 zeros are 0. Remainder is 3. Now after deleting, 3 will be my front. Okay. What is this element? This is what I should delete now. So this is got deleted, right? After deletion, what is my front element? Is updated to third index. Right? Before doing this, first Q of 2 is front is deleted, and after updating, updated front equals to this, right? Now we'll perform these operations on an empty queue. Okay, let's consider a queue. Okay, this is a circular queue. For visual representation, I have to look it like this. Okay, so initially front equals to rear equals to -1. Right, there are no elements in the circular queue. Now I try to enqueue my first element, that is 15. Okay, what should happen here? What formula did I tell you? Rear equals to rear plus 1 mod size. So what is rear? It was -1, then +1. Mod size is, how much size is allocated for this? 4. That means 0 mod 4 equals to 4. So first element is added at 0th position. Okay. Now element is being inserted. Front value is initialized to 0. Okay. Just like the queue, when you're trying to insert first element, that obviously gets incremented or you get updated with this formula. Okay. And front value also gets initialized to 0 when first element is added. Okay. Then again, when you try to add elements, only this rear value will be updated. Now I tried to add 92. So rear equals to, what is present rear value? 0 plus 1 mod 4 is 1 mod 4. So 92 will be added at first position. Okay. So when you try to write in the exam, keep drawing one circular one structure for each time you insert nodes. Then your answer will be prolonged. Again, I am adding one more element, 34. Rear equals to, what is my rear value right now? This is my front. This is my rear. Okay. So what is my rear? 1 plus 1 mod 4 is 2 mod 4. That is 2. Okay. So 34 will be inserted at second position. That is rear. Okay. Again, I try to add 96. So again, rear equals to, what is my rear? 2 plus 1 mod 4. 3 mod 4 equals to 3. Now last element will be added at third position. Now I'll try to insert elements once. See, here rear equals to rear plus 1 mod size equals to 5. Okay. For it, we have considered this condition. What does it mean? If rear equals to 3 plus 1 mod 4, what does it mean? 0 equals to front. Okay. So if I check this condition for Q is full, R plus 1 mod size, in case if this is equal to front, then that means the Q is full. So I've evaluated this condition. My rear is 3 plus 1 mod 4 equals to 0. Right? 0 mod 0, 4 mod 4 equals to 0. Now 0 equals to front. That means queue is already full, right? So you cannot add elements into the queue. That means here circular queue overflow condition is occurring. Okay. Now we'll try to delete elements. So what is delete? DQ. Each time I DQ elements, front should be front plus 1 mod size. So what is my front right now? My front is 0 plus 1 mod 4. That is 1 mod 4 equals to 4. Sorry. 1 mod 4 equals to 1. So 15 gets deleted and my front value is updated to 1. Okay. After this, I try to delete one more element. So it becomes 1 plus 1 mod 4 equals to 2. If you delete this element, this became front now. Okay. Now try to insert element. So I'll try to insert an element. My element is 63. So for insertion, rear plus 1 mod size. What is my rear right now? 3 plus 1 mod 4. Rear equals to 4 mod 4. That means 0. Now rear is pointing to here. Now my new element 63 is added at 0th position. So after completion of my n-1 position, I am directly going to 0th position. Right? This is how you NQ and DQ elements in a circular queue. So let's say there is only one element in the queue. Okay. My element is here. Okay. Now, so this is only front, this is only rear. Front equals to rear equals to same. Okay. Both are same. So after dequeuing, it becomes front equals to rear equals to -1. Okay. After deleting that single element which is present in the circular queue, then front value, rear value are initialized to -1. Okay. Now you have deleted this element also. Okay. So now front and rear are -1. Okay. Now you try to perform DQ operation again. So what happens? Circular queue underflow condition occurs. Right? So this is how you perform insertion, deletion operations, that is NQ and DQ operations in the circular queue. I hope you all understood how to work with the circular queues.